So the first thing we want to do when moving from a single server setup into AWS is actually create yet another server. We need to create another server so that we have somewhere to put our application. So I have no servers here running with the search for onboarding, so I'm going to name a server here, onboarding. I've clicked into the EC2 console. I'm in the instance pane. It's going to show me the list of instances in this account. I can just go ahead and go to launch instance. The first thing we need to do is pick our base image. An AMI is an Amazon machine image, and it's basically a base server image that we can create our server on. Now, there's a lot of flavors here. There's quick start, which are ones that are managed by AWS, but there's also community AMIs when there are many of these. And there's others in AWS Marketplace where you actually end up paying extra per hour to get some kind of managed or pre-installed and pre-configured software. We are going to go right to quick start, and we're going to go down to Ubuntu 20.04, which is what we've been using, especially it's what we're using in Laravel Forge, the same server, so we'll keep with the same server type. You do have the option of x64, so Intel or AMD CPUs versus ARM-based CPUs if you'd like here, but I'm going to keep with the x64 type here. We'll select that, and then we have to choose from this huge list of server types. What do you choose? I'm not going to go into it in too much detail here, but in the EC2 Essentials course that's free on Cloudcast, I cover the various instance types, as well as all the variations within a server type, right? So we have T3 here, there's the T3A type, and there might be like a T3D or a T3N. There are many variations of server type, which I'm not going to get into here because it gets kind of deep, but that is covered in the free EC2 Essentials course on Cloudcast if you want to check that out. So the cheap ones are the T2s and T3s and the T4Gs. T4G here is grayed out because these are ARM-based instances, and I selected an AMI that is not ARM-based, right? It was x64-based, so Intel or AMD chips. That puts me in the T3A or T3. So T3 are Intel-based CPUs. T3A are AMD-based CPUs. They're a little bit cheaper. I actually recommend using them mostly because they're a little cheaper and the performance for a PHP application just doesn't matter that much. So I'm going to go T3A Medium, which is 2 CPUs and 4 gigabytes of RAM. Now, the T2s and T3s, I won't get into too much detail of this, but these work on a credit CPU system. So that means you have to keep an eye on your CPU usage to make sure you don't use up your CPU credits, because if you do, your CPU will get capped at a certain baseline if you use up all your credits. There actually is also a thing called unlimited mode, so that if you run out of CPU credits, you don't get capped, but you do pay a little bit extra per minute or something like that of usage in that mode. Anyway, we're going to use the T3A here. Now, the T2s and T3s are cheaper, which is why people make that trade-off between that CPU credit system and the server type. So we're going to go ahead and just do that here. I'll have 2 CPUs and 4 gigabytes of RAM. It'll be a pretty solid server, especially for a PHP application, especially for a PHP application where the database and Redis and all that stuff is not on the same server. So actually knowing that, I could even go way lower here to even a nano if I wanted to, because that would probably serve most PHP applications well with half a gig of RAM because the database is no longer on that server. I'll actually just go with the small in our case, so 2 gigabytes of RAM, because sometimes installing packages with Composer for PHP libraries needs a little bit more RAM. Okay, so next we get this big list of options. This is kind of the big scary list of things that were unknown to a lot of us when we were creating an EC2 server. What do all these options mean? A lot of this you can just ignore for most people's usage of AWS. Now, that's not true for everyone, of course, and these options, of course, exist for a reason, but we can go ahead and ignore a lot of this, especially when we're just kind of moving over another server for a different provider into AWS so we can use their services. Okay, so number of instances, I'm just creating one, but of course you can create multiple if you'd like when you're spinning up servers with AWS. Purchasing options, spot instances we can ignore, but spot instances is kind of like a marketplace where you can get servers at a much cheaper price, but AWS is going to give you a 2-minute warning at some point and shut your server down on you. So they're often used with auto-scaling groups, and they're used with applications or use cases where it doesn't matter if a server gets killed because another server will spin up and replace it and just continue on whatever work it was doing. So you get a huge reduction in price in return for having to make a fault-tolerant application that can have a server spin down and die all of a sudden. Often used with auto-scaling groups behind load balancers when there are multiple servers and that kind of thing. Network. Network is a whole thing. The VPC, the Virtual Private Cloud Service, provides you a private network. This could be a whole little course in itself. I'm using the default VPC, which is a VPC, a network that is created in every single region within your account. It'll also auto-assign public IP addresses to any server you put into any networks, any subnets within that network, so that server will be accessible from the public internet. Now, you could also just say disable here. Don't assign it a public IP address. So while your server will end up in a subnet that is technically public, it won't be accessible by the outside internet because it doesn't have an IP address. But at the same time, it also won't be able to reach out to the outside internet. So you have a trade-off to make there. If you need a server in a network that is private, in other words, it can speak to the internet, but the outside internet can't speak to that server, then you need to make your own VPC. I have a video of that up on Cloudcast. That's the VPC Basics course, which explains all of this in much more detail. Here, we can go ahead and know that we are going to have a server that needs access to the internet, and the internet needs access to that server so that it can serve web traffic. The default VPC, therefore, is great. Any subnet is fine. I have no preference, so AWS is going to select one of these three for where to put the server, and I want a public IP address to be given to the server so that I can make web requests against the server, so I can accept web requests. Hostname type is just the name that the server gives itself. DNS hostname, so the hostname that is set up will resolve to the IP address in the private network for the server. We'll just keep with IPv4 because IPv6 is just more complicated. You probably don't need placement groups. These help you create your server in a certain way so you can try to create all of your EC2 instances on the same physical host or spread across different physical hosts and all that kind of good stuff. The default is just fine there. Capacity reservations are basically like you can say, I'm going to need 5 EC2 servers. I'll pay for all 5, but I'm only going to spin up 2 for them right now. If I need those 3 extra ones, then I have the capacity reserved and I can just spin those up without having to worry about running out of capacity, because it is possible for a region to run out of capacity. So it'll tell you it can't create that server type. Sorry, I'm out of capacity for that server type. It's rare, but it happens. You can join a directory. This is kind of like Active Directory stuff. An IAM role is a role that has a policy that gives your server permissions to do stuff against the AWS API. We don't need that right now, but that is kind of common to use. CPU options are really only used if the software on the server has some kind of license that requires you to pay per CPU core or something like that, or even threads per core, which is why you can specify CPU options to limit that on your server types. So typically don't use that. Shutdown behavior, if you stop your server, it's either going to terminate it or just plain old stop it. So stop is typical. Hibernation is, I believe, some Windows-based behavior that you can do. Enable termination protection, so make it harder to delete your server by accident. Monitoring is always enabled, but it only sends data to CloudWatch, the place where those graphs exist, like your CPU usage and disk usage and stuff like that. Monitoring by default sends data to CloudWatch every 5 minutes. So if you enable monitoring, you're actually just bringing that down to every 1 minute instead of every 5 minutes for a small additional fee. EBS optimized instance. Everything now is basically EBS optimized. The EBS drives are the disk drives on the server, and optimized is just feature they made that makes them better and faster and higher bandwidth and that kind of stuff. Almost everything is EBS optimized. I can't even uncheck that. Tenancy. So shared is the regular model, but there's also dedicated and dedicated host. Those are all expensive options, dedicated varieties. So shared is the typical model that most people are using. Elastic inference, just like this little pop-up box says, it is enabling a feature that gives you some more GPU power on your servers in case you need that for something like machine learning and hopefully not mining crypto. Credit specification. So in a T3 instance, T3s have a CPU credit system, as I mentioned before. This is the unlimited feature, which is on by default for T3 and T3A type servers. I talk about this more in the EC2 Essentials course, which is a free course in Cloudcast that you can check out. Basically, it just says that if you run out of CPU credits, your CPU usage doesn't get capped, but you also pay an additional fee for when you're in that condition. File systems, this is actually a network file system, NFS, that you can add to your servers and attach it. Enclave is some special setup for extra security where your server is in an extra secure space. No CPU or disk or anything like that is shared with other resources at all. Typically not used except for very special use cases. Metadata you usually keep on. This is very specific to AWS and the IAM role stuff up here, usually related to the permissions thing, because the metadata service that runs on every EC2 server is what gives your server access to make calls against the AWS API if your code is making calls against the AWS API somewhere. Just usually keep that enabled. V1 and V2. V2 is normal. It's token-based for some authentication stuff. It's not really a big deal. You can keep these by default if you want. User data is kind of neat because user data lets you generate a script that only gets run the first time the instance is ever spun up. So I could do like apt get update and apt get install -y something. Your user data can basically be a bash script that you run, but we're going to skip all that. We'll do this a different way. Okay, storage. So GP2 is the default selected when you're spinning up a server. For some reason, GP3 is newer and better and slightly cheaper. The reason why is because you get a baseline of 3000 IOPS, which is operations per second, and a throughput of 125 megabytes per second. So you get that with GP3. GP2, for certain disk sizes, will only give you a little bit of IOPS, right? 100 here. And that grows with the size of your disk. And then it caps out at 3000 IOPS. You get a burst, and it has a burst balance similar to the CPU credits. GP3 is basically better. There's no burst balance. You just get 3000 IOPS. So I'll keep that 8 gigabytes is totally fine here. In general, just use GP3. Add tags. It is good to tag your instance. I usually at least give it a name tag. This is going to be the onboarding AWS instance. That's what I'll name that. But you can add other tags, especially things like environment, that kind of good stuff. Those are all very important tags to have. So you can search by and filter out your instances and all that good stuff, and even add specific tags to as a cost reporting tag. So that'll show up in your bill specifically. You can actually see your bill and cut it up by environment and that kind of thing if you set certain tags as cost allocation tags. Security groups. Okay, so this is an important one. Security groups are specific to the VPC. So we're using the default VPC. So if I create a new security group here, it's going to be created in that default VPC as part of it. Security groups are basically a firewall, but it's not on the server. It's on AWS's network layer, but it is just like a firewall. By default, all access is blocked. So your security group is going to allow certain traffic. So here, it wants us to create a new one, but we can actually select existing ones, and you can select multiple, right? So I have one here called SSH testing, and that's going to allow in SSH type traffic, which is port 22 TCP traffic from any location. So I'll select that, and you can select multiple. So the HTTP one is going to allow port 80 and 443 TCP traffic, in other words, HTTP and HTTPS traffic from any location as well. So I'll select both of these. So those two security groups are going to be associated with the server, thus allowing me SSH access and HTTP and HTTPS traffic. Let's review and launch. This is basically just saying these are all the options you selected. That's great. I'm going to launch, and then it's going to say, wait, you need to select a key pair. And if you don't have a key pair, it'll ask you to create one. You can create a new one here if you want. I'm going to choose an existing one because I already have these. These are a key pair that you use to SSH into your instance. So I have one named Cloud Class Forge. I acknowledge that I actually have this private key, so I can actually SSH into the server. So let's go ahead and launch this instance, and we can see they've initiated. So this is the ID of the instance. I can click on that, and it's just automatically going to filter in that instance here in my list of running instances here. So that's up and running. It's still initializing. It'll take a second before I can actually SSH in. So in the next video, when this is done, we'll see how I can log in and poke around in the server, and we'll start configuring this server to run our PHP application.